Thanks for joining. And what we have done yesterday in previous session that we have discussed about TOS, type of service, and in TOS we have basically two parts. One part is COS, that is label to classification and marking, and then other part is so TOS. What parts we have? One is COS, right? Class of service. And other part is IP DSCP. DSCP like that is layer 3 marking. And one was layer 2 marking. Like that, we have discussed these things earlier. And when you are studying this, it's very important to know that your COS having these 3 bits reserved, 6th, 7th, and 8th. So because if you have 3 bits, so maybe your total number of markings will be 2 to the power 3, that means 8, right? Like that. You can see here how many markings we have. So for COS, 1, 2, 3, 4, 5, 6, 7 markings are reserved. If you start from 0 to 7, that means 8, right? And then the label 3 marking that you have 6-bit reserve. Somehow this 6-bit means 2 to the power 6. That means how much? Maybe 64, right? 2 to the power 6. So that you can see here that that DSCP marking, we are mapping with the COS. So TOS, the DSCP, we are mapping with the COS. And you will see that in the COS, also you have low priority, high priority, and medium priority, like low, medium, and high priority, right? So this is something that you need to understand, right? If you understand this marking and this thing, it's become easy. And if you understood this particular chart, this chart is actually very, very important cheat sheet type of summary type of chart related to QS. Finally, you can see that we have ECN as well, 2 bits reserved for ECN. And we should have some slide related to ECN so we can discuss. Otherwise, I'll explain you about this. Okay. So now this is something that you can see that, okay. So now you're showing me the full chart. Like in chemistry, we have some chart related to different elements like helium, lithium, and others. Like that, you have this chart. So now we have this full chart, and then this particular chart, how we can utilize in the device. Okay, so let's try to understand that. This is best practices points, and it's very interesting. Sometimes things are mixing and they are connected. So always perform QoS in hardware. Try to perform hardware QoS first, then the software. Classify and mark the application close to their source as technically and administratively feasible. See, you know, nowadays this close to source, close to their sources, this particular section. Actually, nowadays we are trying to do the routing as well close to the source. So close to source is one thing that other technologies also we try to implement close to source, not only QoS, but other things also we're trying to do close to source. Then police unwanted traffic, enable queuing, right? So we should understand this queuing as well, that what is queuing, and different hardwares, they have different queuing mechanism. Today we will go and discuss one queue technology. Now this is one small diagram, and this is very important because um, you will understand everything in this, and it is telling you that, okay, I have trusted port and I have untrusted port and I have conditional trusted ports where you can go and create some policies rule for conditional trusting. Now you can see between switch to switch, you can go and enable some IP DSCP trust, and in our lab also we have to do that. You can see between switch to switch, we are enabling those ports as a trust port because you can go and control these configurations and all and traffic and all. Now, when your switch is going to some access point, this is also Cisco access point and all. So there also you can go and enable the trust. But when you are going to terminating devices, such as video conferencing devices or IP telephony devices, there you can go and put some conditional trust, some conditional values. But when you are going to dead zone, where you are terminating the network, like printer or biometric devices or any other handheld devices, there you are making this untrust endpoint. That means over this interface, you have to go and create security policies. So anything that is coming from untrusted over this interface, this switch will try to block this because this is untrusted, right? That's the meaning of this trust point. Again, you can see that like that, you can go and mark the trust and untrust. You can go and mark them as a DSCP marking, and you can go and do the conditional queuing and other QoS configuration as well that we will see in the configuration part. Now, let's focus only on one hardware, that is Catalyst 2900 series switch. Although this switch, you can see nowadays everything is moving to Catalyst 9000, but still you have Catalyst
Yes, yes, yes.
2000, Catalyst 3000 in the network, right? So how we can go and do the queuing, how we can go and do the hardware queuing, how we can go and understand the QoS between the 2000 series switch. Because if you understand 2000, you can understand 3000, 6000, 4000, 9000, etc. Let's try to understand this. Now it is telling that such type of switches, they have this arrangement. This arrangement means one priority queue, three queue, and one threshold, right? You can see here. So what does it mean? One priority queue means that in this particular priority queue, you can go and put a voice packet, or you can go and put the network control packet, such as OSPF control packet, STP control packets, etc., etc. Right? Then you can see that non-priority queues after that. So once your 1P, so this is actually 1P. Once your 1P is done, then you have non-priority queues, right? In non-priority queues, as per your classification, and here the traffic classification will come into the picture. So now in your non-priority queue, as per this spectrum, you can go and put first of all high priority to the call signal, mission critical and other traffic, then network transaction and transaction data to other queue, and then best effort to the default queue. So suppose if you have 4 queue, then as per your DSCP marking, as per your classification, here you are putting the voice traffic, for example. Then you are putting business critical, business critical application, and then you are putting some maybe non-business, but these are still important traffic. And then you are putting some default, whatever default is there, like your maybe file share, not file share, but what default traffic we can use? Anything that is not coming in the wires and mission critical and non business important traffic. Anything like YouTube traffic or maybe Facebook or um, torrent or peer applications, whatever. N number of applications are there, which is a non-business related traffic. You can put in the default queue, right? So what does it mean? While we are doing such type of classification, what's the use and how it will be? And it is not that easy that I'm explaining here. You need to understand this structure. Now you will understand with this diagram. This is actually a very interesting diagram and it will take some time to understand. Now let's try to figure out this. So what I'm telling here is this, that okay, you have your network control traffic, right? Network control traffic and inter network control. These are the control packets. So these control packets you want to give high priority. You can see here that in this queue, I have 1P, 1 priority, 3Q and 3T threshold. Okay, so threshold means that you can go and define the threshold means reaching 100% and then do the policing. Reaching 85% and over 85% you have some buffering like that. You can go and use some mechanism related to maximum threshold in a queue. So what does it mean? We'll try to understand this. Let's try to figure out this. So now if you see here that the network control and the CS6, what are these? CS6 and CS7, class selector 6 and 7. If you see CS6 and 7, they are in the bottom. They have very high precedence DSCP 48 and 56, right? They are something that you have to give the high priority. So now you will see here in the diagram that this is going to Q2, right? This is what Q2. And this is going to Q2 and threshold 3, maximum threshold. So it is in Q. Now this is 1P. You are saying this 1P, right? 1P priority. This is priority queue. This is also a queue. So how many queues we have in this? First of all, try to understand this. So if we start with Q1, you have Q1, you have Q2, you have Q3, and you have Q4. Now this Q4, you can see in this diagram, this Q1 is nothing but your priority queue.
Priority queue.
Okay, this one queue is nothing but one queue. It is a queue. 1P is nothing but one queue. Okay, that means you have actually 4Q and 3T. This is priority queue. That means this is next level priority queue. This is after that priority queue, and this is the Q4 is the default priority queue. I will see that how it is in this diagram. Okay, so where we are, WIP, that's the EF, expedite forwarding. EF is a DSCP, highest level marking, expedite forwarding. Where it is going? It is going to priority queue. So now you can see in priority queue, we have EF, CS4 and CS5. So CS4 and 5, they are video and conferencing, right? Then class selector 4, CS4 is also going there. Some because you can go to this diagram slowly, you will understand. So CS4 and CS5 actually going here, but AF4 will go assured forwarding level 4. So in AF, you will find AF1, AF2, AF3, AF4 like that. This number, this higher number means high priority, right? So now you can see AF4 AF3, AF2, and CS2. This is going to Q2. And this is something that I need some more bandwidth reservation. So that's why it is 30%. Okay. So it is going to Q2, but I told you earlier that this is Q and 3T, means one Q having three threshold. So now in Q2, you can see that we have Q2 threshold 1, Q2 threshold 2, and Q2 threshold 3, right? It's a little bit confusing, right? Hmm. How we can understand this? Okay. Um, what to do. Okay. Think this is the switch 2960. Now in this switch, if packet arrive here, then you can go and do the queuing, because queuing is basically software based. So now you may have Q1, Q2, Q3, Q4. Now one of the queue you're marking as a priority queue. Priority queue. This is your 1P, right? So in this priority queue, what type of traffic you want to send? So I want to send the traffic related to voice, etc. Why voice related? Because voice traffic, they have the latency less than 150 millisecond. So you have to give them high priority, otherwise their logic will go. They will self-destroy. Okay, then you have rest of the queue. But these rest of the queues that you are seeing here, because since this is, for example, 1P, 3Q, and 3T, 3 threshold, that means that these queues further you can go and divide in different thresholds. So that means that this queue number, so this is, suppose this is Q1, and then you have Q2, and then you have Q3, and then you have Q4. So what I'm telling that these queues, oops, this is actually Q2. These queues that you are seeing here, they are divided into different level of priorities, right? And not only the priority. So Q1 having priority. So in Q1 there is no threshold, but in Q2, Q3, and Q4 we have the threshold, right? So you can think this as a Q2 T1, and then T2, and then T3. Threshold level 1 to, oh, sorry, it should be 3. Threshold level 1, 2, and 3, right? So T1, T2, and T3. Okay. Like that in Q. So Q2 T1, Q2 T2, Q2 T3, Q3 T1, T2 T3, Q4 T1, T2, T3, right? So according to that, you can go and do the marking, classification and marking. So now Q2 is High priority queue means for business related um, high priority traffic, and then this you can think as a medium priority, and then this you can think as a low priority, or maybe you can think as a default, whatever not categorized in queue 1, 2, 3, they will go via queue number 4. Right, now let's go quickly and see the arrangement here. Now this diagram is a little bit hard to see, so can I go ups and remove this diagram? Okay. Okay, so now you will see that you have Q1 you understood, right? It's very easy because there is no threshold in that. So you can easily understand this Q1. No problem at all understanding Q number 1. Then you can see Q2 having 3 threshold. And in Q2, actually this is business related traffic. We have CS2, CS3, and then we have AF assured forwarding. So we can say the real-time traffic, multimedia conferencing, then signaling, then multimedia streaming, right? Then CS5 is not there, and CS4 is not there. So like that, most of the traffic related to businesses we have here. Now, even the transactional data as well, you can see that is in Q2. Then you can see Q number 4, where we have the bulk data. Now, you can see bulk data, where it is in Q number 4, T1 and T2. Even the scavenger and bulk data, they are going to queue number 4. This is the default queue, right? Then you can see that we have this queue number 3, where we have this Q3. Actually, Q3 and Q4, that is there for scavenger data. Now, this is not the exact way that we can also go and configure. This is just the Cisco reference. Cisco is telling to classify, to do your QoS configuration like this. Okay? You have any doubt in this? Okay, do not worry because I'm going to cover the same concept but little bit with more complexity with other platforms as well. So now if you go and configure this 2960, you will see that in the configuration, you have to go and first of all enable this multi-layer switch QoS, MLS QoS. And once you enable that, then then you have to go and do such sort of marking. So QoS cost to DSCP marking 0. This is what DSCP. Trust the cost setup, trust the DSCP setup, and then you have to go and trust different devices. Right. This is the standard configuration. Everywhere you'll find the same related to QoS, and then you have to go and do the rest of the configuration as well. Okay, I'll come to this configuration later on. But this understanding this slide was very important. If you have any difficulty, please feel free to ask.